Dear students, welcome to my 4th class on Module 5, Sampling Theory. In this lecture video, we're gonna discuss the problems based on the sampling theory. Example number 1. A coin is tossed 1000 times and head turns of 540 times. Decide on hypothesis that the coin is unbiased. So the first step in this problem is formulating the hypothesis. So I'm going to formulate the hypothesis like the coin is an unbiased coin. So now we have to check the hypothesis is true or not. So to prove this one, so first let me define the events P and Q. So P shows that chance of getting head in one toss. So as we know that tossing a coin one time, the possible outcomes will be either head or tail. So total we are having two outcomes. So now chance of taking one head out of two outcome is 1 by 2. So we can tell the value of P will be equal to 1 by 2. And Q is nothing but what? It is 1 minus P. So by calculating this, Q is equal to, we got 1 by 2. And here this N shows that the number of trials. So in this problem, that coin is tossing 1000 times, the trials will be 1000. So I can take N is equal to 1000. So now I am going to calculate the expected number of heads in 1000 tosses. So it is given by N into B. So 1000 into 1 by 2, it will be equal to 500 we will be getting. And the actual number of heads is given by 540 times. So so X will be equal to 540. So now I am going to test the hypothesis with the help of the following formula. The formula is given by Z is equal to X minus NP by square root of NPQ. So replace all these data over here. So we got 540 minus 500 divided by square root of 1 by 2 into 1 by 2 into 1000. This will be equal to 2.53, which is less than of 2.58. So hence we can say that the hypothesis is true. The coin is an unbiased one. Example number 2. In 324 throws of a 6-faced die, an odd number turned up 181 times. So can we think that the die is an unbiased one? So same like a previous problem, here also first formulate the hypothesis. The hypothesis says that the die is an unbiased one. So now we'll be defining events P and Q. So here P shows that chance of getting odd numbers in throwing a die once. So as we know, in throwing a die once, the possible outcomes will be what? Either 1 or either 2, either 3, either 4, either 5, either 6. So we have six possibilities here. And out of these 6 numbers, the odd numbers will be what? 1, 3, 5. So now, chance of getting odd numbers in throwing a die one time. So what will be getting? So 3 odd numbers out of 6 possible outcomes. So it is 3 by 6. So therefore, the value of P will be equal to 3 by 6. So P is 1 by 2. So to calculate Q, the formula is Q is equal to 1 minus P. So we got Q is equal to 1 by 2. And the value of N is given by 324 because the die is throwing for 324 times. So now the expected number of odd numbers in 324 throws we have to calculate, that is N into P. So N is 324, P is 1 by 2, it will be equal to 162. And the actual odd numbers, X is given by 181, so the value of X will be equal to 181 here. So now to test the hypothesis, so take the formula, that is Z is equal to X minus NP divided by square root of NPQ. So replace the data over here. So X is equal to 181, NP is 162 divided by N is 1 by 2 into 324. So by simplifying this, we got the value of Z is equal to 2.11, which is less than of 2.58. So hence we can say that the hypothesis is true. The die is an unbiased die. Example number 3. A die is thrown 9000 times and a throw of 3 or 4 was observed 3240 times. Show that the die can not be treated as an unbiased one. So here I will do one thing. I am going to take the statement in one way and I am going to prove that hypothesis is wrong here. So like I will frame the hypothesis like the die is unbiased die, and I am going to prove finally my hypothesis is not true. So for this one, I am going to define the events P and Q. So let P be the chance of getting the numbers 3 or 4 in a single throw of a die. So as we know that in throwing a die one time, the possible outcomes will be 1, 2, 3, 4, 5, 6. So in that outcome, so choosing 3 and 4. So choosing 3 and 4, total 2 possibilities we are having out of 6 possible outcomes. So that is 2 by 6. So then the value of P will be equal to 2 by 6, that is 1 by 3. So we got Q is equal to 1 minus P, that is 2 by 3. And we have N is equal to 9000 trials here because the die is throwing for 9000 times. So N will be equal to 9000. So now I am going to calculate the expected number of success. So that is N into P out of 9000 outcomes. So 9000 into 1 by 3, it will be equal to 3000 after simplification. So now I'm going to calculate the observed number of success out of 3240 times. So X will be equal to 3240 is the observed way of getting the outcomes 3 and 4. So now I'm going to test the hypothesis with the help of the formula, that is Z is equal to X minus NP divided by square root of NPQ. So this will be equal to 3240 minus 3000 whole divided by square root of 1 by 3 into 2 by 3 into 9000. So after simplifying this equation, we got the value 5.37, which is greater than 2.8. So hence our hypothesis is wrong. So hence we can say that the die is a biased die. Example number 4. The problem is like this. A school over a period of 5 years, 725 students has passed and 615 students has failed. So test the hypothesis that the success and failures are in equal proportion. The first thing is that we have to calculate the value of N. So to calculate the value of N, I am going to add the pass ratio and fail ratio to calculate the total strength of the school. So therefore, the total number of students will be equal to the number of pass students plus number of fail students. That is 725 plus 615. It will be equal to 1340. So now I am going to calculate the observed proportion of success. So it is given by how? 725 success divided by total strength, that is 1340. So we got 0.54 is the value here. So now we have to define the events P and Q. So so I'll be taking P as a success ratio and Q will be failure ratio, and they have given that this pass and fail ratio both are in equal proportions. So since it is equal proportions, I'll be taking P is equal to 1 by 2 and Q is equal to 1 by 2. So now we'll check the hypothesis is true or not. So to calculate that one, so we have to calculate the value of Z is equal to X minus mu by sigma. So now to calculate this X minus mu by sigma, so I'll first find the value of X minus mu. So I'm taking X minus mu over here, that is 0.54 minus 0.5. So we got X minus mu is equal to 0.04. So now sigma we have to calculate. So sigma is nothing but what? Standard deviation. So the standard deviation formula is square root of PQ divided by N. So hence we got the sigma value is square root of 0.5 into 0.5 divided by 1340. So the value of sigma is 0.0014. So now I'm going to replace this X minus mu and sigma value in the main formula. Therefore we got Z is equal to X minus mu by sigma, that is 0.04 divided by 0.014. It is 2.86, which is greater than 2.58 we got. So hence we can say that the So finally we can state that the hypothesis is wrong here. So hence the success and failure are not in the equal proportion.